All right, this is chapter 1-1 on points, lines, and planes. Take a little pretest for yourself and see if you can match the words with the corresponding figures. Let's see how you did. A line matches with figure B. A ray matches with the figure at D. A point matches with the figure at A. A line segment matches with the figure at C. We're going to go a little bit more in depth on these and add a few more vocabulary words. First one we're going to look at is a point. A point names a location. So to name this location, we're going to need to put up what we typically look at is the coordinate plane. So here we have our coordinate plane. P is at the coordinate 4, 4 and is in quadrant 1. Now when we talk about points, we always use a capital letter. In this case, P. This is point P. Next, if we look at a collection of lots of points all right next to each other, we get a line. Now a line is perfectly straight and extends forever in both directions. Now we want to talk about a specific line. One thing that we're going to need to do is pick 2 points on that line. So we're going to need our coordinate plane. So now I've picked 2 points on this line, point A and point B. So if I want to talk about this specific line, I'm going to talk about line AB. So I'm going to write it as capital A, capital B, with a line above it, because it is a line AB. Notice above AB, the line has arrows on either side. That is important. It shows that it extends forever in both directions. Going with that, another thing we can look at are what are called line segments. Now, a line segment is the part of a line between 2 points. So again, I'm going to pull up 2 points here. In this case, C and D. But what's different about a line segment in comparison to a line is if you'll notice on the figure, the arrows are gone. A line is just between the 2 points. A line segment is just between the 2 points. So when we talk about this line segment, we're talking about line segment C, capital D, with a line above it. And notice no arrows on that line. It is just between point CD. When we start looking at lots of different points on the same line, we get what are called collinear points. Points that lie on the same line are collinear. So on this line segment CD, I can put lots of points. And I can name them, point A, point Z, and point Q. Doesn't really matter. All right? But those points are all collinear because they're all on the same linear line. Next, we're going to be talking about rays. A ray is part of a line that it starts at one point and extends forever in one direction. So first of all, we need a point. Of course, a point needs to be on a coordinate plane. So here we have point M, okay? And if I want to put in a ray here, I'm going to need, here we go. I'm going to need to extend that line through point R, and notice it goes on forever with that arrow. So again, this ray MR starts at point M and goes on forever through point R. So when I start writing about this, I'm going to write M first because the ray starts at M, and then R because it extends forever through R. And I'm going to draw a picture above it so I know I'm talking about ray MR. The way, or the order you put those letters is very important. So we know which point you're starting at and which point the ray goes through. Now if we put multiple rays together, we get what are called opposite rays. Opposite rays are 2 rays that have a common endpoint and form a line. So if I were to add another ray here starting at M, going in the opposite direction, say through point, I don't know, G for Mr. Gustafson. Now I have opposite rays, MR and MG. Those 2 rays are opposite rays. and they form a line. Next, we're going to look at planes. Now, this one is tricky. A plane is perfectly flat surface that extends forever in all directions. Now, the book will typically use a picture that looks like this, a rectangle, well, a parallelogram. And there will be at least 3 points on a plane, A, B, and C. All right, that is a plane. Now, a plane does not have to be a parallelogram. Plane does not have any specific shape. If I draw that, that's a plane. All right, I could maybe call that plane M. And in your book, you will notice that sometimes a plane will just have points on it. Sometimes a plane will have a capital cursive letter on it. There are 2 ways to name a plane. All right. One way would be to name the parallelogram plane, plane C, A, B, or any arrangement of those letters. Could be plane B, C, A. As long as they are 3 non-collinear points, which means 3 points that are not on the same line. You'll notice points A, B, and C are not on the same line. You could also call this weird shaped figure down at the bottom plane M. And that's all it would be called, was plane M. Okay? Now to confuse things even more, we talk about points that lie on the same plane are called coplanar. So points A, B, and C are all coplanar because they all exist on the same plane. If I were to add a point on my plane M down here, and we'll call that point G, plane A, B, and C are not coplanar with point G because all 4 are not on the same plane. Point B and point A are coplanar. Point B and point C are coplanar, but point B and point G are not coplanar because they do not exist on the same plane. So let's see what you can do. I would like you to name 2 points in the figure and name a line in the figure. So take a second, pause, and see if you can do it. All right, for A, there are lots of answers for A. Name 2 points in the figure. I'm actually not going to write them all down, but you could have said anything from J and K. You could have said K and L. You could have said L and M, or any arrangement of those 4. Those are all points in the plane. R is not a point in the plane. Name a line in the figure. Well, again, a couple different options here. A line, remember, extends in both directions forever. So you would have to have JK as a line. Don't forget you need to have the picture above it, the line above it with arrows. You could also have said line LK. And again, your line above it. Now, if you had put line KJ, that would be just fine because you're just picking 2 points in the figure or on that line and you're putting a line above it. Again, you could have also said KL. The order on a line is not as important as the order on an array. So those are your answers for that one. Last one here, I believe. Name 2 segments in the figure. Name 2 rays in the figure. So take a second, pause, see if you can do it. All right. So name 2 segments in the figure. I'm not going to write all these down because there's way too many. But you could have said JK. I'll write a few. Make sure that your line above it does not have any arrows. You could have said MJ. You could have said ML. You could have said LK. Now notice LK and JK are also lines. But because we don't care about it going on forever, we can talk about just the space between J and K as a line segment. So you could have reordered any of those as long as you have something similar to those four. Name two rays in the figure. Here you are a little bit more limited. There's quite a few options though. You could have started with J and gone on forever through K. You could have started with K and gone on forever through J. Going backwards there. You could have said K, L, or L, K. Those would have been perfectly acceptable answers. Just make sure that it has to have an arrow going on forever in one direction. Order does matter with rays. That is very important. For a line and a line segment, order does not matter. For a ray, order is very important. I believe that's it. So good luck.